So the previous example that we've been just looking at, this one, to get this general solution here, let's plot it on autograph and we get this. And so if we actually put this on autograph here, then what I've plotted is one of the explicit forms, and you can see it here, y equals log x squared over 2 plus k. I've just added a constant k rather than putting it inside. And if I change the value of k, so if I go to the constant controller and change the value of k, you can see what it does to the function. In other words, this model might be describing something that's going on in the situation that I'm interested in, and it's going to have the same shape but to give me different values depending on k. So I could do with knowing what k is. So this general solution gives me the shape of the function, but which shape I'm interested in, let's just reduce the step size a bit, which exact shape I'm interested in will depend on the value of k. Because I want at the end to be able to look at a value of x, say x equals 2, and go up and across and see, well, what is the value of my function when x equals 2, or whatever it is. Well, that value will change depending on the size of k. Oops. So we're going to need to know what these constants are. And something else we can take from this is that we can see that actually our model won't work for certain specific values of x. It won't work when x equals 0 because it's all shooting off to infinity at x equals 0. So I can say that this graph is a solution of the differential equation. Notice that y tends towards negative infinity as x tends towards 0. So we need to specify that this solution that we've come up with for this differential equation works if x doesn't equal 0. And if we go back and look at our function, our explicit function, then we could almost predict that, because if I put into my calculator the natural logarithm of 0, I'll get a maths error because it's heading off towards negative infinity as I go to 0. So we need to be able to say when this model works and when it doesn't, because we're going to try and apply it to a real situation. Lots of